In this lesson, I'm going to discuss solving a compound inequality. Here is one type of compound inequality. 4 is less than negative 2x is less than 8. So this is a continuous interval, something between 4 and 8. Now to solve this, I could break it up into two separate inequalities, but we're going to go ahead and leave it as is, and this is the trick that you do. I'm going to go ahead in the middle and get x by itself. So in this case, all I have to do is divide by negative 2. So I just need to do it to the right side and to the left side, because it's the equivalent of combining two inequalities together. Now you'll notice that I divided by negative 2. So that means I'm going to need to reverse my symbol here on both inequality signs. And so I say that I have my x has to be less than negative 2, but greater than negative 4. So from an interval point of view, I'm going to have one continuous interval. Now these are inequality that do not have the equal sign. So what I'm going to do is I have to start with the smallest number, which again, look at the pointed end of the inequality sign. It's pointing to the smallest one, because we know negative 4 is less than negative 2. So the interval is between negative 4 and negative 2. And since they're not equal, we're going to put the curved parenthesis. Now to graph that interval, we know it's between negative 4 and negative 2. So let's go ahead, and I'm just going to go ahead and mark this is 0. So this would be negative 2, and this would be negative 4. So it falls in between negative 4 and 2. Now again, there's not an equal sign with our inequality. So to do the graphing on a number line, I need to use the open circle on both ends. And then I simply fill in the line that connects the two, because it's between negative 4 and negative 2. So that's graphing my compound inequality. Let's take a look at another one. Now this one is set up separately because it's not a continuous. I have x minus 3 is either less than negative 2, which would be off to my left, or x minus 3 is greater than 2, and greater than 2 would be off to my right. So I'm actually going to solve these separately. So we'll take the first one. Add 3 to both sides. I get x is less than 1. Now I work on the other inequality. Add 3 to both sides, and in this case, x is greater than 5. So this is a separate, you can see 1, less than 1 means I'm going to the left on the number line. X greater than 5 means I'm moving to the right of 5. So they're not combining. So we have to have two separate intervals. And here's the key, the word or. So my first one, since it's less than 1, goes all the way to negative infinity. And then it reaches the number 1. The or means union. So now I'm going to put my union symbol. So my answer is either between negative infinity and 1, or it's greater than 5 and off to positive infinity. That U represents my or statement. So graphing, I'm going to go ahead, it's between, I need 1 and 5, so I'm going to make this my 0. This will be 1, 2, 3, 4, 5. So the left interval starts at 1. And again, it's an open circle on this example because there's not an equal to sign. It goes to negative infinity, so it goes off this way. And I'll use my arrow to signify it goes forever. The second interval on the right starts at 5. Again, open circle on 5, and it's greater than 5, so I'm going to go off to the right. So that is an inequality that has separate intervals. One more compound inequality. Negative 25 is less than or equal to 6x plus 5 is less than 11. So we'll start with our algebra by taking the 5 from both sides. So that's going to give me 6 In the middle I have 6x. And on this end, negative 25 and negative 5 is negative 30. So now finish the middle by dividing both sides on the ends by 6. And we get x is less than or equal to 1. It's less than or equal to negative 5. So again, I have a continuous interval. It's between negative 5 and 1. So continuous intervals get a single interval notation. Starts at negative 5 because it's the smaller number, goes to 1, and I'm using the square brackets because in this example it's less than or equal to. So since it's a single interval, that means my graph is going to be a single piece. So we'll go ahead and we'll make this our 0 point. This will be, this will be 1. This will be negative 1, negative 2, negative 3, negative 4, negative 5. So on 1, I'm going to put a solid dot, because again, there's an equal sign with my inequality. I'm going to go down to negative 5 and put a solid dot. And in between the two, I'm going to connect the dots. And that's my interval notation and my interval graphing.